If you've ever had a migraine or know someone who has, you know it is so much more than just a bad headache. Today, we're going to completely reframe how we look at them, removing past some really old ideas and looking at migraines through the modern lens of nervous system regulation. So let's dive right in and unpack the science.
For the longest time, the main idea was the migraines were a vascular problem. Blood vessels in the brain just spasming, opening and closing. But honestly, that picture is old news. The new, much more accurate idea is that a migraine is fundamentally a disorder of nervous system imbalance. It's not about one broken part. It's about the whole system being out of whack. And trust me, that shift in perspective changes absolutely everything. To really get a handle on this, let's use an analogy. I want you to picture your nervous system as this incredibly complex and sensitive power grid. A migraine isn't one wire breaking or a single fuse blowing. Nope, it's more like a citywide brownout. It's a total overload state that happens when the demand on the grid is way more than it can handle, and the whole thing struggles to stay stable. Okay, so that's the big picture. But what's actually happening inside the brain to create that intense, unbearable pain? Let's zoom in and unpack the core mechanism of a migraine attack.
All right, meet the main player in this story, the trigeminovascular system. I know, it's a mouthful. But basically, this is a huge network of nerves that does two main jobs. It controls sensation in your face and head, and it manages blood flow. Think of it like the main circuit board for your head. When a migraine gets triggered, this system is ground zero. It gets overloaded, and that kicks off a whole cascade of events.
And a key molecule in this whole process is something called CGRP. When that trigeminal nerve gets activated, it releases this protein. And CGRP is a big deal. It's a powerful vasodilator, which just means it makes blood vessels widen, and it unleashes a wave of inflammation that basically turns the volume way up on all the pain signals. This, by the way, is exactly why so many of the newest migraine medications are designed to block CGRP. And here is where it gets really crucial. When this pathway gets activated over and over again, it can lead to something called central sensitization. This is a wild concept. It's basically where your brain learns to be more efficient at creating pain. It's why during an attack, things that are normally totally fine, like light, sound, or even just a gentle touch, can feel absolutely agonizing. The brain's entire alarm system is just stuck in the on position. So, if that trigeminal system is the pain switch, what's supposed to keep it from getting flipped all the time? Let's zoom back out from the microscopic stuff and look at the major systems that are supposed to keep our power grid stable and running smoothly. First up, we've got the autonomic nervous system, or the ANS. You can think of it as the body's automatic traffic control. One of its main jobs is to carefully manage blood flow in the brain. But when you're in a state of chronic stress, that fight or flight branch of the system can get stuck in the driver's seat. This creates a ton of instability, causing those blood vessels to erratically constrict and dilate. And that chaotic fluctuation, that can directly cause that classic awful throbbing pain. Next, let's look at neuroinflammation. It sounds complex, but just follow the flow here. It starts with a trigger. Could be stress, could be something going on in the gut. This activates these little immune cells in your brain called mast cells. Then, those cells release a cocktail of inflammatory chemicals, which in turn makes that trigeminal nerve we talked about even more sensitive and way easier to trigger. It's like it's priming the system for an explosion.
And you can't talk about a power grid without talking about the power plants, right? In our cells, those are the mitochondria. And your brain is an energy hog. It needs a massive amount of power to run properly. When the energy supply can't keep up with demand, your brain cells, or neurons, become unstable. They get hyperexcitable. And this energy crisis is thought to be what can trigger something called cortical spreading depression, a slow-moving wave of weird brain activity that is the most likely cause of migraine aura.
Okay, so we've covered the core systems, but now let's talk about some of the other factors that can put extra strain on that power grid, making the whole system much more vulnerable to a migraine. And it's important to be really clear here. The science for some of these connections is still emerging, so we have to be careful. But the research is getting stronger and stronger, suggesting these factors are definitely associated with migraines and they can absolutely contribute to lowering that trigger threshold. We can kind of group these stressors into a few key areas, as you see here. We're talking about hormonal shifts, the whole gut-brain connection, tension that comes from your neck, and even overactivation of the emotional centers of your brain. Each one of these can pour a little more stress on an already strained system. Let's just quickly break down how these work. Big swings in hormones, especially estrogen, can directly affect blood vessel stability.
That gut-brain axis? Yeah, inflammation that starts in your gut can actually lead to more inflammation in your brain. All that chronic neck tension from hunching over a screen, it's sending constant irritation signals right into the pain processing centers of your brainstem. And finally, chronic stress puts your emotional brain on high alert, which actually dials down your body's natural, built-in ability to block pain.
Phew. Okay, that is a lot about what goes wrong. So, what's the path forward? This is where we shift our entire focus. We move away from just suppressing pain and toward actively trying to restore balance to the entire system.
Because when you look across all of these different mechanisms, the vascular stuff, the inflammation, the energy problems, the hormones, the one common thread that ties them all together is a loss of regulation. The system has lost its ability to adapt, to stay stable. It's become rigid and reactive instead of being resilient and responsive.
So the real goal isn't just to find a better way to shut down the symptoms when they happen. The bigger strategy is about building a more robust system from the ground up. We're talking about supporting your health at the cellular level, learning how to manage that stress response, and actively helping the nervous system become more stable and resilient. And this really leaves us with a profound question to think about. What if the goal isn't to be in a constant war, fighting the pain? What if instead we saw the pain as a signal, a message from a system that is under an incredible amount of strain, and our job isn't to shoot the messenger, but to focus our efforts on retraining that system back towards stability?
Because ultimately, all of this science points to a really hopeful conclusion. Migraine is not some life sentence of random, unpredictable attacks. It's an output from a system that needs rebalancing. And when we truly understand the physiology and we start working to help the nervous system find that balance, what we often see is that both the frequency and the intensity of the migraines begin to decrease. It's a fundamental shift from fighting a battle to restoring an entire system.